Hello students, welcome back to the next module of our chapter called electromagnetic induction. Now students, in this particular module also we'll be continuing with the numericals which are based on Faraday's law, right? So let us start with the numerical. It says a metal rod 1 by root pi meter long rotates about one of its end in a plane perpendicular to the magnetic induction of 5 into 10 raised to power minus 3 Tesla. Calculate the number of revolutions made by the rod in RPM if the EMF induced between the ends of rod is 15 millivolts. Right? Now let us write the given data. Now here students, we are provided with the rod. The length of this particular rod is 1 by root pi meter. Right? And this particular rod is placed in a magnetic field of induction 5 into 10 raised to power minus 3 Tesla. And it is kept perpendicular to the plane, right? So let's say here magnetic field is perpendicular to the plane of rod and it is directed inwards, right? Now this rod is rotating, right? And students, see carefully, as the rod is rotating, it will cut magnetic lines of induction. And according to Faraday's first law, whenever rod or a conductor cuts the magnetic lines of induction, an EMF will get induced between the two ends of rod, right? And in this case, induced EMF which is provided is 15 millivolts. And what we are supposed to calculate? Here we are supposed to calculate the frequency of revolution of this particular rod, right? Now let us write down the given data. Here we are provided with metal rod which is 1 by root pi meter long, and this will also act as a radius. So I can say R, it is equal to L, and it is equal to 1 upon root pi meter, right? It is placed in magnetic field of induction 5 into 10 raised to power minus 3 Tesla. So therefore I can write B, it is equal to 5 into 10 raised to power minus 3 Tesla, right? EMF induced, it is 15 millivolts. So I can write E, it is equal to 15 millivolt, which can be further written as 15 into 10 raised to power minus 3 volts, right? Now students, what we are supposed to calculate? Here we are supposed to calculate the number of revolutions which is made by the rod per minute. That means we are supposed to calculate the value of frequency F. And the formula that we'll be using is from Faraday's second law, E, it is equal to mod of d phi by dt. And another formula that we'll be using is number of revolutions per unit time, that is N upon dt, it is equal to F, which is nothing but the frequency, right? So we know given data, we know the formula to be used. Let us start with the solution, right? Now students, we know that from Faraday's second law, E, it is equal to mod of d phi by dt. Right? Now students, in this case, since the field is perpendicular to the plane, phi will be equal to B into A. So therefore I can write d dt of B into A. Right? Now students, in this case, the magnetic field is uniform and it is constant. And as it is constant, it will come out of the differentiation sign. Right? And in this case, as the rod is rotating, it is sweeping some area. That means the value of area swept is changing. So I can say A is variable where B is constant. So we can take out B outside. So what we'll get? We'll get this will be equal to d dt of B into dA by dt. Right? Where B is constant and dA by dt represents area swept per unit time. Now students, in one revolution, area swept by the rod will be equal to pi r square. Right? So in n revolution, the rod will sweep the area equal to n pi r square. So I can say change in area which is given by dA will be equal to n pi r square, and that will happen in time dt. Right? Now we know value of dA. Right? We also know value of EMF. We know that E, it is equal to B into dA by dt. Now we know value of dA. What is value of dA? It is n pi r square. So let us substitute the value. So we'll get E, it is equal to B into n pi r square upon dt. Now students, we also know that n upon dt, it is equal to frequency. So what we'll get? We'll get E, it is equal to B into F into pi r square. Right? Now students, this term called pi r square, it is equal to area. So this EMF will become B into F into A. Right? Now let us take it further. So we'll get E, it is equal to B into F into A. Now we'll rearrange this particular formula to get the value of frequency. So therefore I can say frequency F, it is equal to E upon BA, right? Now students, see the given data. We know value of E. We also know value of B. Now as radius is known, we can calculate the area as well, right? So let us substitute the value. So this will be equal to, value of E is 15 millivolts. So this will become 15 into 10 raised to power minus 3. Value of B, it is 5 into 10 raised to power minus 3. So we'll get 15 into 10 raised to power minus 3 upon 5 into 10 raised to power minus 3 multiplied by. Now area is given by pi r square. Now value of radius is given, it is 1 by root pi. So if I square the radius, I'll get 1 by pi. So area will become pi into 1 by pi. So from here we can cancel out 10 raised to power minus 3. We can also cancel out pi, right? After cancelling, we are left with 15 upon 5, which will come out as 3. So therefore I can say frequency F, it is equal to 3 RPS, that is revolutions per second. Now students, but we are supposed to calculate frequency in RPM. So we'll multiply this by 60, and what we'll get? We'll get frequency F, it is equal to 180 RPM, that is 180 revolutions per minute. So students, in this particular module, we have covered one numerical which is based on Faraday's laws of electromagnetic induction. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.